In this video, we'll use Excel to convert base 10 numbers to other bases and vice versa. And we'll use the methods that students usually first learn in classes when they learn about these other bases. There are some fancier, more efficient methods, but they're also harder to understand. So let's start with the direction that most people find easier. We're going to write a number in a different base in these yellow cells. This cell over here tells us the base, 5, and our base 10 equivalent is going to come over here. Now we'll start by making a formula that will tell us the value of each place. So that's the ones place, and our next place is going to be equal to the base. And now we're going to multiply the place to the right by the base to get the new place. And in order to do that, I'm going to make up a formula. So my place to the right, I'll click in, times the base. Now I'm going to hit F4 to make that base an absolute reference so it always stays the same as I drag the formula. I discuss absolute references more in the multiplication table video I made. Right, so we can take this formula on the right and drag it to the left, and we'll get the powers. Those are powers of 5. We're going to do a different base, base 3. Say we get powers of 3, whatever we want. Let's do base 5. And let's make our number 1, 2, 3, 4 in base 5. Now, to convert this number to base 10, we'd take 1 times 125 plus 2 times 25 plus 3 times 5 plus 4 times 1. There's also actually an Excel function called sum product that does this exactly. So we'll just use that. Sum product of, and then I want to highlight one row and the other row. Those blank squares will just be zeros. So it's the sum product of this row and this row. So it'll multiply corresponding entries and then add up everything. And there we go. 1, 2, 3, 4 in base 5 is 194. If I wanted that in base 6, it'd be 310. Base 7 would be 466. Now, if I want to do something like a base 16, say, if you put something like, say, 2b in, 2, and then b is not going to work. I haven't set this up so it can recognize letters. So I'd actually have to say, okay, the b is equal to 11, and that would work. If you wanted to recognize letters, you can use the lookup function. And I explain how to do this in my base counting 2 video. But let's move and take a look at the other direction now when we start with a base 10 number. So I have the same kind of setup over here with the powers. This is the base we're working in, and I chose base 2 right now because it's smaller powers, a little simpler to understand. But the way we're setting it up will work in any base. And our answer is going to come up over here. I actually want to go through converting by hand first so you can see how this is going to work. So here's where we'll put our number, our base 10 number, 53. And if we want to convert 53 into base 2, well, we start and we say, okay, how many 32s are there in 53? Now, obviously, a bigger number, we'd need more places, which requires more space on the screen, which is why I'm using this number of places, but certainly you should make this with more places. All right, so I say, how many 32s are there in 53? Well, there's 1. And then how much is left? 53 minus 1 times 32 is 21. Okay, now I really do need that 1 times. If I were in a base where I had numbers bigger than 1 to represent the digits, then I would be taking away more than that. All right, so I have 21 left, and I say, how many 16s? Well, there's 1, and then there are 5 left. I have 5. How many 8s? Well, there's none, and I still have 5 left. Say, how many 4s? There's 1. Still have 1 left. How many 2s? None. I still have the 1 left. How many 1s? 1. And now I don't have anything left. So our base 2 number is 1, 1, 0, 1, 0, 1. Okay, so that was the long way. Now we're going to automate it. So what do we start with? Well, we start with, we want the quotient. Let me get this up here. We want the quotient, so we're going to use this int function, which divides and rounds down. We want the quotient of the base divided by that highest place there. Okay, and that is 1, like we want it to be. And then what do we want here? Well, here we want what's left when we start with the base and we take away this times this. So we have the base minus the cell, the highest place, times the number we used for the base. Okay. All right, and that's just like it was before. And now we're ready to automate. So over here, we want to do the same thing we just did with that quotient, but now we want the cell below and to the left, and that is a relative reference, divided by the new place. Hit return there. And then over here, we want the place to the left minus our new place value, our new digit times the place, how much we just took away, what we have remaining. Okay, and then we can drag these formulas. And there we get exactly what we did by hand. Now, except it's automated, so say we want that same thing, 53 in base 3 would be 1, 2, 2, 2. In base 4, 3, 1, 1. And now, again, if we go up to something like, say, base 16, well, base 16 it's 3, 5, so that's not a good example. But let's say we want 43 in base 16. There we have the 2 and the 11. Okay, so this is kind of, it's a little bit, it's not the most sophisticated way to do this, but hopefully it's very transparent. Base conversions.